Example 2 on page 479. I don't really care so much for the story that this is about. What I care about is graphing it. We need to have more experience graphing, and that's what this is going to be about, is the graphing on this. All right, so let's go ahead and graph this one. C of P is equal to 800P divided by 100 minus P. All right, very good example to start with here. Let's run our steps. Step number 1 is the vase. Where does the denominator equal 0 at? What p-value is going to cause that to happen? So what we can do is we can just set the denominator equal to 0 and solve. It looks like in this case p is going to be equal to 100. All right, so we have our vertical asymptote here at 100. Kind of a big value, but again, if we label our graph correctly, it shouldn't matter. Step number 2, the ha. The ha says to take the highest powered item from the numerator, which in our case is going to be 800p, and the highest powered item from the denominator, which happens to be negative p. This 100 doesn't have a power to it. Right? I mean, you guys, you could argue it was 10 squared, but that's not what we're going for. We're going for the variable with the highest power. And then we assess, right? That's what our Roman numerals here talk about, assessing. And that assessment says, what do the powers have in common here? Does anyone greater than anyone else? And as you can see, they're not. The powers are the same. We got p to the first power and p to the first power. So what that means is we get to cross those p's off, and what's ever left over is going to be our horizontal asymptote. In our case, it's 800 over negative 1, otherwise known as negative 800. So it's kind of a smaller one in that it's below the asymptote quite a ways. Step number 3 is the y-intercept. And to find the y-intercept, we normally let x equal 0. We don't have x in this problem. We have p in this problem. So we'll let p equal 0. What that does for us is the numerator is going to be 800 times 0 or 0. Our denominator ends up being just 100. And 0 divided by 100 is 0, meaning that our y-intercept and our x-intercept, or at least one of our x-intercepts potentially, is 0, 0. Let's see if that's the only x-intercept here is step number 4, which is the x-intercept. It says set the numerator equal to 0, so 800p equals 0, which means, yes, that is the only intercept that we have for x as well, 0, 0. Step number 5, the Achilles check. So we take the horizontal asymptote that we found, which was at negative 800, and we set that equal to the function itself. In other words, 800p over 100 minus p. And we try to see if this has an answer. So to solve this, we're going to cross multiply. So we're going to take this negative 800 times 100 minus p, and that's going to give us negative 8 with then 4 zeros, 1, 2, 3, 4 zeros. And then it's going to be plus because you have a negative and a negative, which is going to give us plus 800p. And as you can see here, this one's not going to solve, which is good news. It doesn't have an Achilles point because 800p and 800p, if I bring one or the other to the other side, it's going to kill itself. And so what we're going to have is 80,000 here equal to 0, which of course is not a true statement, which means it doesn't have an Achilles point. Terrific. All right, let's go ahead and draw our Cartesian coordinate system here into the bottom left of this page. And then let's graph this. All right, so what do we know? We know that there is a vertical asymptote here at 100. All right, so somewhere here is 100. Let's go ahead and make this 100 right here. And we have our vertical asymptote, our dashed dotted line that goes right down through that point. Next, we have the horizontal asymptote here at negative 800. So let's go ahead and make this about negative 800 right here. Remember, you have to label that if you're going to not have it be exactly a scale of 1. So there we go, we've done that. And now this is done is broken our graph into 2 sections again. We have the section left of the asymptote. We have the section right of the vertical asymptote. So left of 100 and right of 100. And then within each of those sections, it's either above or below the horizontal asymptote that we've defined. All right, next we know that 0, 0 is a point for the y and the x, so we can put that in right here. That's going to be a pretty good clue that our graph on the left side of the vertical asymptote is going to be above the horizontal asymptote. Do we have any other points to add? We do not. All right, so typically what happens is your graph stays between the asymptotes. It's going to start down here, and then it's going to come up through our y and x intercept here at 0, 0, and then come up and follow this other asymptote this way here. Don't forget to put arrowheads, very important. All right, so that leaves us this section over here to the right. It's either going to be above the horizontal asymptote or below. Now, I might have to do a test point, but here I don't have to, and I'll show you why. If I was above the horizontal asymptote, I would have to go through the x-intercept in order to do that. And obviously, I have no x-intercepts on this side. Therefore, by process of elimination, I need to be below the horizontal asymptote. It's kind of fun that way when you have a horizontal asymptote that isn't zero. When the horizontal asymptote is zero, you have to test when you don't know. When the horizontal asymptote isn't zero, it'll be obvious where it's going to be. It's either above or below. And there's our graph. We did another one. Terrific.